Hello everyone, today we will learn how to better apply sensor data to control the actual operation of motors. When using a photoresistor for line detection, the Arduino analog pin returns raw readings between 0 and 1023. Directly using these values to drive motors or servos presents two major issues. The range is too large, making fine adjustments difficult. Actual control needs often fall within a much smaller range. Therefore, we need to map or scale the raw readings, linearly converting them into a more suitable target range. The core idea of data mapping is to linearly transform the input range to the target range. This is the conversion formula. Taking the conversion from 1023 to 10 as an example. The map value is 10 when the input is 1023. When the input is 511, the mapped value is approximately 5.5. Since our sensor readings only provide integers and do not automatically clip values beyond the range, when mapping manually or customizing the mapping, we must pay attention to rounding or flooring to ensure boundary values are accurate. Clipping the mapped result to avoid exceeding the expected range. Preventing division by zero errors by ensuring the input maximum is not equal to the input minimum. Fortunately, Arduino provides a built-in map function that we can use. The map function is a very useful tool in Arduino, and its core functionality is to map a given input value, x, from one range to another target range. This is the complete format of the map function. X is the original value to be mapped. From low and from high are the lower and upper bounds of the original range. Too low and too high are the lower and upper bounds of the target range we want to map to. When you call map, it linearly scales the input value x based on the given parameters and returns a new map value. For example, this line of code maps sensor value, which ranges from 0 to 1023, to a new range from 0 to 255, and assigns the mapped result to result. It is important to note that map processes only one input value at a time and returns one output value, just as we normally read sensor data one piece at a time. Today, we learned how to use mapping and the map function to process the raw data from the photoresistor. By converting this data to an appropriate range, we can more precisely control the movement of the motor, ensuring that the vehicle performs more stably and reliably. In the next lesson, we will learn about enumeration definitions and state machine programming methods to further improve the standardization and efficiency of the project.